WZBC Newton now begins its broadcast day. WZBC is a Class A non-commercial radio station broadcasting at 90.3 megahertz with 1,000 watts effective radiated output in stereo. WZBC is licensed to the trustees of Boston College with transmitter and facilities located on the campus of Boston College. Newton, Massachusetts. On behalf of the entire staff at WZBC Newton, we hope you enjoy the day. To help make that happen, I'm here, Herbie Perlman, after some technical difficulty setting up. But I'm here. And if you want to get in touch, say hello, to make a connection, to take a deep breath, to Om, to come Om. Well, you can call in, say hello, if you're one of the 36th Lamed Favniks. If you're a little mad at us for what we done, how we allowed Donald Trump, who last time I checked is still president. If you're one of the ones who let that happen, and we all are, and you want to apologize, you can call in at 617-552-4686. But in the meantime, think about this.
Subject, rock and roll. Can I get an amen? Rock and roll has just about brought about the disintegration of our civilization. It has taken a great moral effect upon the youth of our land. The filthy, dirty song that's playing on some of our radio, it has debauched the minds of the young people. Some of the records are so suggestive until even the disc jockeys won't even play. Can you say amen? After a while, God's gonna set this soul well on fire. After a while, this whole world is gonna rock and roll. My master, tell me, my friend, in the days of Daniel, tell me they had a rock and roll party. Tell me they invited the 3 Hebrew boys to the rock and roll party. Tell me that somebody among the boys said, we're not going to bow down to the king's meat. We're not going to eat the king's meat. Good Lord. Tell me that night, my friend, that the old king went to bed. Tell me he had a dream. Couldn't think of what he dreamed. Tell me that they called everybody in the neighborhood. Call all the fortune tellers. Call all the soothsayers. Call all the readers and stargazers. But nobody interpreted the king's dream. But after a while, somebody said, there's a man of God. There's a man of God in the kingdom. They brought Daniel out. Old Daniel came out and stood in the presence of the king. Can I get in there? I read one piece in the paper. A 12-year-old boy shot and killed his mother after he came from the rock and roll. Called my master. Rock and roll causing you steal automobiles so he can be glamorous, so he can take his girlfriend out. Rock and roll is filling up the dope den. Rock and roll all night long. Rock, 1 o'clock rock, 2 o'clock rock, 3 o'clock rock, 4 o'clock rock, 5 o'clock roll. Roll in the patrol wagon, roll in before the judge, rolling out the courthouse, rolling into the penitentiary, rolling into the electric chair, rolling out the undertaker. Rock and roll! You better get ready, cause I'm the rock. My God is gonna break this mess up. He's gonna clean up the world.
Sweet and happy to see those days of which I dream.
Oh, yeah.
And never recall now and then.
Oh, yeah.
Lord, that will repeating sweet. My well heart would be.
So true.
If I could hear my mother pray again. If I could hear my mother pray again. If I could only hear her darling voice again. How happy I would be. It would be so much to me. If I could hear my mother pray again. Lord, she used to pray that would rely.
So true.
Always walk that bright and shiny way. Lord, how sweet and happy to see those days of which I dream.
So yeah,
if I could hear my mother pray again. If I could hear my mother pray again. If I could only hear her darling voice again. How happy I would be. It would mean so much to me. If I could hear my mother
pray again.
Lord, in that old home place, my mother buried there. That prayer she prayed for me is living still.
Oh, still.
Lord, she prayed that I'd find Jesus.
Oh, yeah.
And do his holy will.
So true.
If I could hear my mother pray again. Well, if I could hear my mother pray again. If I could only hear my darling voice again. How happy I would be. It would be so much to me. If I could hear my mother pray again. Well, she used to pray that Jesus would rely. Always walk that bright and shiny way. Lord, how sweet and happy to see. Still, which I dream. If I could hear my mother pray again. If I could hear my mother pray again. If I I could only have my darling voice again, how happy I would be. It would be so much to me if I could hear my mother pray again. Well, Lord, how sweet and happy it seemed, those days of which I dreamed, and never recall now and then.
Oh, yeah.
Lord, that will repeating sweet, my very heart would be.
So true.
If I could hear my mother pray again, if I could hear my mother pray again, if I could only hear my darling voice again, how happy I would be. It would be so much to me if I could hear my mother pray again. Lord, she used to pray that I would rely.
So true.
Always walk that bright and shining way.
Running away.
Lord, how sweet and happy to see those days of which I dream.
So yeah,
if I could hear my mother pray again, if I could hear my mother pray again, if I could only hear our darling voice again, how happy I would be. It would mean so much to me if I could hear my mother
pray again.
Lord, in that old home place, my mother buried there. That prayer she prayed for me is living still.
Oh, still.
Lord, she prayed that I'd find Jesus.
Oh, yeah.
And do His holy will.
So true.
If I could hear my mother pray again. Well, if I could hear my mother pray again. If I could only hear my darling voice again, how happy I would be. It would be so much to me if I could hear my mother pray again. Well, she used to pray that I on Jesus would rely. Always walk that bright and shining way.
Shining
Lord, how sweet and happy to see.
still.
Which I dream.
I dream
if I could hear my mother pray again. If I could hear my mother pray again. If I could only hear my darling voice again, how happy I would be. It would be so much to me if I could hear my mother pray again.
Thank you.
Nothing, go marching on in. Nothing, go marching on in. Well, you know I wanna be, oh Lord, be in the number. Nothing, oh Lord, marching on in. Well, after a while, the will be over, Lord, and after a while, the sun will shine. Well, and all of the dark clouds soon pass over when the same. Marching on in. Well, nothing, go marching on in. Yeah, nothing, go marching on in. Oh, no, I wanna be, yes sir, I wanna be in that number. Nothing, oh yeah, go marching on in. Yeah, nothing, go marching on in. Yeah, nothing, go marching on in. Yeah, you know I wanna be, yes sir, I wanna be in that number. Talking about that number, polarized the number. Talking about that number, no man can number. I've been to the river, I've been baptized, I'm soft and converted. I feel alright, I feel alright, I feel alright. I feel like shouting, just like shouting. One of these old days, it won't be so long. You're gonna look for me, you know I'll be gone. I wanna be in that number of nothing. Yes, Lord, I'm go marching on in.
Highways and dance halls, a good song takes you far. You write about the moon and you dream about the stars. Blues in old motel rooms, girls in daddy's cars. You sing about the nights and you laugh about the scars. Coffee in the morning, cocaine afternoon. Talk about the weather and you grin about the room. Phone calls long distance to tell you how you've been. You forget about the losses, you exaggerate the wins. When you stop to let them know you got it down, it's just another town along the road. ladies come to see you. If your name still rings a bell, they'll give you damn near nothing, and they'll say they knew you well. So you tell them you remember, but they know it's just a game. And along the way their faces all begin to look the same. And when you stop to let them know you got it down, it's just another town along the road. Well, it isn't for the money, and it's only for a while. You talk about the rooms, and you roll away the miles. Gamblers in the neon, clinging to guitars. You're right about the moon, but you're wrong about the stars. 'Cause when you stop to let them know you got it down, it's just another town along the road.
got to move. When the Lord gets ready, you got to move. You got to move. You got to move. You got to move. Well, you got to move. When the Lord gets ready, you got to move. Tell the high, tell the low, tell the rich, tell the poor. When the Lord gets ready, you got to move. You got to move. You got to move. You got to move. Oh, you got to move. When the Lord gets ready, you got to move. You may be crippled, cannot walk, may be blind, you cannot see. When the Lord gets ready, you got to move. Oh, 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 hey, 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 hey. I got to move, I got to move, I got to move, and I'm glad about it. When the Lord gets ready, I got to move. Oh, 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 hey Lord, I got to move, yeah, I got to move, I declare, Lord, I got to move. Oh, when the Lord get ready, oh, I got to move. Tell the world, tell the low, tell the cripple, they got to go. When the Lord get ready, they got to move. You got to move. Hey, 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 ha, ha. Oh, no. When the Lord gets ready, you got to move. You may be crippled, you cannot walk, you may be blind, but you cannot see. When the Lord gets ready, hey, hey, ah, la, la. Well, 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 well. You got to move. Hey, 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 oh, oh, hey, hey, hey.
if it takes all night, that'll be alright. If I can get you to smile before I leave, looking out at the road rushing under my wheels, I don't know how to tell you all just how crazy this life feels. Look around for the friends that I used to turn to pull me through. Looking into their eyes, I see them running too. Running on empty, running blind, running into the sun, but I'm running behind. Honey, you really trip me, you know the way you look so kind. I'd love to stick around, but I'm running behind. Running on, you know I don't even know what I'm hoping to find. Running blind, running into the sun, but I'm running behind.
Thank you.
This is from No Recipe by Edward S.B. Brown. The section called Purifying Our Love. We practice Zen to purify our love. Suzuki Roshi. In The Unsettling of America, Wendell Berry's premise is that a significant portion of American culture over its lifetime has been characterized by the mind of exploitation. We get what we can get out of a situation, place, relationship, and then we move on, heading west into the setting sun, running on empty. We don't have to clean up the mess we left behind. Whether it's pollution, land laid to waste, or our relationships gone sour. We're on the make, setting out to hit our next score, or to score on our next hit. But who's keeping score? Always there are greener pastures unadulterated with our previous presence. Pastures that we are seeking to exploit for our own profit. without concern for the costs in human misery or despoliation of the earth, without acknowledging side effects or collateral damage. We use it up, wear it out, make do without, and then move on. We also call this capitalism, the free market. People make money at the expense of others and at a cost to the environment. Berry contrasts this with the mind of nurturing, when we're in it for the long haul, in reciprocal relationship, tending the garden as it grows, circling around the stupa, washing over our children as they mature into adulthood. We clean up after ourselves so that we have a decent place to live. There's no moving on to what has not yet been spoiled. We cultivate caring, compassion for others, so that we live in harmonious convergence on the creative connectome. We attend to our spiritual life so that we have direction that comes from the Sadguru within and beyond. And not just the incentive to profit at the expense of others. We practice Zen, Suzuki Roshi explained one morning in the old Tassajara Zendo, to purify our love. He elaborated, usually our love is associated with some idea of gain, some thought of what we will get out of it. As we purify our love, we are shifting from the mind of exploitation to the mind of nurturing. We shift from our head to our heart, from thinking about how to get and have, to feeling how to connect and benefit ourselves and others. This is not about what you should or shouldn't do. Be kind or don't be selfish. No, but rather about choosing where you put your awareness and noticing that where you put your awareness can be like a gift or a blessing. When you can share the goodness that is inside with the world outside, then the garden grows, the food arrives, and your family flourishes, and your tantric, ahimsic, akashic, artistic, shamanistic, synesthetic Sangha creates its own weather, its own climate change. Inside, last virtual cipher refugia in the Wolfram Alpha computational ubiquiescence. You take a deep breath. The kitchen can be a place for purifying your love, shifting your thinking from what you can get out of it to how you can offer your time while you're in the kitchen. This is something we keep deciding how to spend our time. And even the concept of spending your time is already off the mark, as spending probably means you would want to be making great purchases with your accumulated effort and its monetized results. Perhaps gifting works better. How will you choose to gift your time?
Well, no more, no more, never no more, no more. I'll never turn back out in this whole world anymore. Stormy ride, wind may blow, rain may come, they may go, but I'll never turn back in this world anymore. Well, no more, no more, never no more, no more. I'll never turn back out in this whole world anymore. Stormy ride, wind may blow, free may come, they may go, but I'll never turn back in this world anymore. One day I started out for heaven, it was a long time ago. Jesus brought me safe over the rough and rocky old road. Well, I've been up so many times, I've been down in my life. Well, but I'll never turn back. I'll never turn back. I'll never forget today. Jesus washed my sins away. Stepped down in the water. Water was cold. Chill run at your body, but not my soul. You can talk about me just as much as you please, but the more you talk, oh, I'll bend my knee. Stormy ride, wind may blow, free may come, they may go, but I'll never turn back. Oh, I'll never turn back. Lord, I'll never turn back. Stormy
You're listening to WZBC Newton 90.3 FM. Any views or opinions that you might hear on this program are not the views of this station, Boston College, or its Board of Trustees. No, sirree, Bob. Them people wouldn't think in this way. This is also from Edward S.B. Brown, No Recipe. It's called Not Wasting. The most important point is to express your true nature in the simplest, most adequate way, and to appreciate it in its smallest existence. Suzuki Roshi. Although I am going against the current, I want to share with you some of the ways that I practice not wasting. For starters, I buy sensibly just what we can eat at home. At the homes of others, I am often struck by the opulent displays of fruit, and I cannot help but wonder whether it is also being eaten and not just used for viewing. They must eat a lot more fruit than I do. 50 years later, as I continue to reach out for the heat-resistant rubber spatula, one of my students refers to my doing this as Ed Browning it. Though I rather hope that this does not go into general parlance, I am grateful when someone notices and willingly undertakes this practice of not wasting. Perhaps my practice of thoroughly cleaning the food out of pots and off of platters is religious fanaticism or rigid compulsion. Yet with this practice, my aesthetic has changed. The time, quote, wasted, unquote, while saving food has become time saved while preparing dishes in the following days. Rinsing our pots and pans after cooking with a small amount of water and setting them aside to use later adds flavor to my soups and vegetable dishes. Although I am going against the current, I want to share with you some of the ways that I practice not wasting. For starters, I buy sensibly just what we can eat at home. At the homes of others, I am often struck by the opulent displays of fruit, and I cannot help but wonder whether it is also being eaten and not just used for viewing. They must eat a lot more fruit than I do. 50 years later, as I continue to reach out for the heat-resistant rubber spatula, one of my students refers to my doing this as Ed Browning it. Though I rather hope that this does not go into general parlance, I am grateful when someone notices and willingly undertakes this practice of not wasting. Perhaps my practice of thoroughly cleaning the food out of pots and off of platters is religious fanaticism or rigid compulsion. Yet, with this practice, my aesthetic has changed. The time, quote, wasted, unquote, while saving food has become time saved while preparing dishes in the following days. Rinsing our pots and pans after cooking with a small amount of water and setting them aside to use later adds flavor to my soups and vegetable dishes. It also makes the pots easier to clean. The leftovers on the bottoms of pots become new meals rather than garbage in the sink. Occasionally, I find someone willing to take on this practice of shifting how they relate to food, willing to develop new skills, new ways of working, new ways of using their bodies to care for food. For it is a body practice, something you do and not just something you think about. It is one way of purifying your love, as there is no telling what you stand to gain from this practice. You do it because you decide to do it, because you are moved to do it. The effort comes from inside, largely unvalued by the outer world. Often people make excuses. We can afford it. Why bother? We don't waste food, it gets composted. Nothing is ever truly wasted, it simply transforms into something else eventually. Understood. We value our time and wish to make good use of it. While this may be true for food, the continent of plastic in the Pacific is growing larger, and it's not going away in our lifetime. Yet food is not just food. It is the blood, sweat, and tears of human endeavor, as well as the burning of fossil fuel. With so much food these days, there is an energy deficit in that more calories of energy are used to get food to the table than there are calories in the food. And food waste is incredible. I do not know how to summarize this, but I can direct you to feedingamerica.org, where you can begin to learn about this matter. Last year, the Feeding America Network and its partners diverted over 2 billion pounds of safe, edible food that might otherwise have gone to waste to Americans facing hunger. An estimated 25 to 40% of food grown, processed, and transported in the United States will never be consumed. Most people don't realize how much food they now throw away. From uneaten leftovers to spoiled produce. According to the EPA, about 95% of the food we throw away ends up in landfills or combustion facilities. We dispose of more than 35 million tons of food waste in 2013 alone. In an article in The Atlantic, published July 2016, Why Americans Lead the World in Food Waste, I learned that, quote, roughly 50% of all produce in the United States is thrown away. Some 60 million tons, or $160 billion worth of produce annually, an annual amount constituting 1/3 of all foodstuffs. Bottom line thinking comes up with all the reasons that it's just not worth it to find ways to waste less food. Whether it's the large amounts our culture neglects or the smaller ones at home. In the flow of all that is being consumed and disposed of, it is indeed a formidable challenge to consider what is worth saving and to undertake the necessary steps to waste less. Usually, when people do not scrape out the bottom of a pot, they also do not save 2 or 3 inches of leftover cereal. They may leave 3 or 4 inches of peanut butter at the bottom of a 5-gallon barrel, and then leave the barrel floating in a sink of soapy wash water to clean. I've also seen jars of peanut butter, honey, or jam discarded with 1 inch or more left at the bottom. What is wrong with these people? Wasting less means forming an intention and then acting on that intention. Making use of leftovers begins with making them in the first place. Often people cook way more than enough because they want to be sure of not running out, not running on empty. My aim is that we run out just when people have enough to eat. Sometimes providing too much food to eat begins with buying more than we can use. When I teach cooking classes, I really aim to make what we can eat. Still, people will buy more than the quantities I have ordered. To prepare it all, we then need to work extra hard to make extra food that we will not eat. So during the preparation for class, I sometimes get out the scale. Let's weigh this and use only what we are going to eat. At home, I don't have a menu for the week. I go through the refrigerator to see what needs to be used, and I use it. Almost no food is wasted. Soups often accept my offerings. I also save plastic bags. At home, I wash plastic bags and dry them, often on top of bottles on the floor. After they are dry, I fold them so that they fit neatly into other plastic bags that I can take with me when I go shopping. I estimate that I have saved 15 bags a week, perhaps 500 bags in a year, and 5,000 bags in 10 years. And I've been doing this for more than 10 years, maybe 20 now. Is it worth it? A particle of dirt on the summit of some wholesome deeds, an offering, a ceremony, something I can actually do. See what you think. What is precious in your capacity to find things, moments of your life, precious moments.
This is Radio Eco Shock with Alex Smith.
Another big wheel of the climate shift has turned. Young scientist Levka Caesar reports the Atlantic overturning current, including the Gulf Stream, has definitely weakened because of climate change. It will add to global warming and affect hundreds of millions of people on both sides of the Atlantic and around the world. Likewise, the drying of southern Europe has begun. Spain could be a desert within a lifetime. Also from Germany, expert Luis Samaniego forecasts European drought from fossil fuel burning. This is science at its best and at its most frightening. And this is Radio Eco Shock. The wild change in ocean currents portrayed in the disaster movie The Day After Tomorrow has now been confirmed by science. No, not the sudden freezing disaster shown by Hollywood. But if you are concerned with weather in the eastern United States, Canada, the UK, and Europe, or if you are worried about global climate change itself, this is for you. Multiple layers of science demonstrate the great ocean current, popularly known as the Gulf Stream, has weakened significantly since 1950. 2 papers on the overturning of the Atlantic waters were published in the April edition of the prestigious journal Nature. One is led by the Potsdam Institute for Climate Impact Research, or PIC. The well-known scientist Stefan Rahmstorf was deeply involved, but here the lead author is PhD candidate Levka Caesar. This is her first paper, and published in the top journal Nature, no less. From Potsdam, Germany, Levka Caesar, welcome to Radio Eco Shock.
Yes, thank you.
Before we get to the many impacts of big change in the Atlantic, we do need to understand what it is. When you talk to the public, Levka, how do you explain the long technical term Atlantic Meridional Overturning Circulation, or AMOC?
Well, I like to emphasize that what we call AMOC is not just a single current. So it's not just the Gulf Stream, but it's actually a major current system in the Atlantic Ocean, and the Gulf Stream is just a part of it. And this current system is actually mainly characterized by a warm flow of waters in the upper layers of the Atlantic, going from the tropics to the higher latitudes. And there, the water cools, it releases heat to the atmosphere, and as it cools, it becomes denser, because cold water is denser than warm water. It sinks to deeper layers in the ocean, and then we have a southward return flow at those deeper layers. And due to this warm flow of waters in the upper layers, and then a flow of colder waters in the deep layers of the Atlantic, we actually have a net heat transport from the tropics to the high latitudes that is carried or done by this overturning circulation.
And we will talk about the regional impacts that interest so many millions of people on both sides of the Atlantic. But first, what about the global climate change that affects everyone? Now, while researching your paper, I came across a 2014 study led by the University of Oxford scientist Yavor Kostov, and it begins, quote, "We propose here that the Atlantic Meridional Overturning Circulation, or AMOC, plays an important role in setting the effective heat capacity of the world ocean and thus impacts the pace of transient climate change. Livka, do you agree if the Atlantic overturning slows down, could that hasten the arrival of climate impacts because less heat is dropping down to the deep ocean?
Well, this is a complex question, and we have to look here at two opposing effects, perhaps acting on different timescales. So what this study showed is that, well, the AMOC helps to transport heat downwards into the ocean, as we have this overturning circulation with waters moving to or sinking to deeper ocean layers. But another effect is that when we have a slower overturning circulation in the Atlantic, we have less heat that is released to the atmosphere at high northern latitudes from the ocean. So I think there has to be more research done to study this effect. But one thing that is probably going to happen is that the ocean region in the North Atlantic is a major sink of carbon dioxide. So it's a region where the ocean takes up a lot of carbon dioxide from the atmosphere and then stores it in the deeper waters of the ocean, which is because we have colder surface waters there, and carbon dioxide is actually more easily solved in cold waters than it is in warm waters. And then, due to the overturning circulation, we have waters moving from the surface to the deeper ocean, and we have a transport of carbon dioxide from surface waters to the deep ocean. And when this overturning circulation slows down, we will likely have a positive feedback on the CO2 concentrations in the atmosphere. That is, the ocean will take up less carbon dioxide from the atmosphere, and thus the CO2 concentrations in the atmosphere could rise more quickly. So we expect feedbacks on climate as the overturning circulation is changing, but we have to study them in more detail.
Okay, let's go back to the beginning. In North America, the public knows this current as the Gulf Stream, and it's only part of it, as you say. But where does that Gulf Stream begin, and where does it get its heat?
Well, the Gulf Stream is kind of the part that flows along the east coast of the U.S. And where does it get its heat? Well, it transports water from the tropics, and in the tropics, the water is heated by the incoming solar fluxes. And when these warm water masses are fastly moved upwards to the North Atlantic, then they just take their time before they slowly release the heat to the atmosphere, and thus we have a transport of warm water masses towards the higher latitudes in the North Atlantic.
How does the Gulf Stream affect the weather along the American eastern seaboard and the maritime provinces of Canada, and in what seasons?
This is a really complex question you're asking there, because weather is determined by a variety of factors. And when looking at the Gulf Stream or the overturning circulation, we rather see effects on long-term climate. So I'm sorry, but I can't in-depth answer this. But what we know is, or what studies have already shown, is an effect on the sea level at the American east coast.
So would it cause the sea level to go higher or lower if we have these changes in the flowing of the current?
It will actually lead to an increased sea level rise. So we have a sea level rise because warmer ocean water is expanding, and therefore under global warming we have a general sea level rise. But, and this is more complex, so I'll take some time to answer this. As you know, the Earth is rotating, and therefore we have on all moving things on Earth the Coriolis force acting. So this normally means on the northern hemisphere that when somebody is moving from the south towards the north, and it doesn't matter if this is me or you or an ocean current, it is forced to move towards the right-hand side. And so for a current to move from the south to the north without being deflected this much, the sea surface has to tilt with lower sea levels at the U.S. coast and higher sea levels in the mid-Atlantic, and then you have a force acting from the mid-Atlantic from the high sea levels towards the low sea levels, which can counteract this Coriolis force. So this is one point. Then the Coriolis force is stronger when the current is faster. Therefore, this tilt has to be more steep when the current is faster. Now, as the current weakens, the Coriolis force gets weaker and the tilt in sea level height also becomes smaller. And this leads in the mid-Atlantic to lower sea levels, but at the U.S. East Coast to higher sea levels. Well, this is a physical mechanism that is actually, it's simple when you know about it, and it's kind of nice to really understand because it's a simple link. And this, has already been seen that we have increased sea level rise at the U.S. coast due to slower ocean currents.
I learned a lot from what you just said. Okay, your paper's mainly about the velocity of Atlantic Ocean currents, but is the Gulf Stream also changing its location or direction?
Okay, so what we show in our study is actually that there is a change in the location of the Gulf Stream. This is actually also basic physics. So, as I said, the overturning circulation is weakening. And this means that also this deep southward return flow from high latitudes towards the tropics is weakening. And when this deep return flow is kind of following the east coast of the U.S. and then it downslopes at the area of the Gulf of Maine due to the bottom topography there, it leads due to what we call vorticity conservation, which is also related to the Earth rotating. It kind of causes the Gulf Stream to deflect from the U.S. coast because it induces another recirculation gyre there. So this is complex, but the main point is the deep return flow causes the Gulf Stream at some point to deflect from the U.S. coast, and when this return flow becomes weaker, the Gulf Stream can actually follow the coastline a little bit further north and then deflect later towards mid-Atlantic. So we see an effect on the Gulf Stream, but you have to keep in mind that the Gulf Stream is also forced by wind changes or by the winds in the atmosphere over the Atlantic. And so changes in the Gulf Stream are not just due to changes in the overturning circulation, but other changes, for example, in the wind forcing will also show in the Gulf Stream. So it would also be great to study just the Gulf Stream itself in more detail, because now we focus on the overall overturning circulation.
There was a second study published in the same issue of Nature in April 2018, led by David Thornalley of the University College London. How does that relate to your study?
Well, basically, Thornalley and colleagues also looked at different climate parameters to infer information about the evolution of this overturning circulation in the Atlantic, but they went further back in time. So they used what we in climate science we call proxies from different core sites. So proxies means you can't measure something directly, and you look at other parameters to get information. So they had a temperature-based proxy, and then they also used sorted silt data. And this sorted silt data basically gave them information about the current velocities of the deep flow of the Labrador seawater. So basically saying, depending on the size of the grains, you could kind of get information about how fast the current was. And they saw that this current got weaker towards the mid-19th century. Yet you have to keep in mind that this might not represent the full overturning circulation, because they used two core sites, and this is a rather local proxy then. Or they also looked at a temperature-based proxy with a little bit more data, which is similar like ours because it's based on the same idea, namely that when the overturning circulation in the Atlantic weakens, we have less heat being transported from the tropics to the high northern latitudes, and therefore you can see a cooling in the sea temperatures there.
Why do you say the change in the Atlantic overturning brought on by human-induced warming is greater than anything seen in the last 1,000 years?
Well, basically because that's what the data shows us. This relative temperature in the North Atlantic is colder as it was at any time in the last 1,000 years. So the temperatures in the North Atlantic with respect to the global mean temperature is really being at its deepest level right now, or its lowest level right now.
Yet, as Stefan Ramsdorff points out, a smaller ocean change in the currents appears at the end of the Little Ice Age, as it's called. Around 1860 was the end of it, and before a meaningful amount of fossil fuels were burned?
Well, this is correct because, the fossil fuels itself, or the burning of fossil fuels itself, is not the direct link to, or doesn't directly slow down the overturning circulation, but it is the increased melting of both the Greenland ice sheet and the Arctic sea ice, so the increased meltwater flux into the ocean, into the North Atlantic Ocean, that is causing the slowdown of the overturning circulation. And we know that at the end of the Little Ice Age, or the so-called Little Ice Age, there was a time of increased melting of the Greenland ice sheet, presumably natural at that time, which then also caused a weakening in the overturning circulation, but that weakening wasn't as great as what we observe right now.
And you mentioned the melting of the Greenland ice sheet and the sea ice that is disappearing, but also increasing precipitation is a factor.
Yes, exactly, because increased precipitation over the North Atlantic and the surrounding land areas basically also leads to an increased freshwater flux into the North Atlantic due to the river runoff. And that is the point. It's the freshwater flux that is kind of hindering the engine, or what I would call the engine of the overturning circulation. Namely that at some sites in the subpolar North Atlantic, you have places where water, due to it becoming cooler and being relatively salty, is so heavy at the surface that it has to sink down because the water layers below it are not as dense. So this dense surface water is sinking towards the deep ocean. And then if it's down there, it has to go somewhere, and then it flows south. So this is really what is keeping the overturning circulation going. And with this freshwater influx, the water is less salty. And if the water is less salty, it's not as dense, not as heavy, so it's more difficult for it to sink. And we therefore hinder the deep water formation that is driving the overturning circulation by increasing these freshwater fluxes into the northern Atlantic.
Radio EcoShock.
You are tuned to Radio EcoShock. I'm Alex Smith. My guest is Liefke Caesar from the Potsdam Institute for Climate Impact Research in Germany. We're talking about a new paper in the journal Nature. It confirms the Great Atlantic Convection Current is weakening with serious repercussions on both sides of the Atlantic and around the world. The press release from PIC, the Potsdam Institute, reports the Atlantic overturning current has reduced by about 15% since 1950. How do you know that, Liefke?
Well, what we really observe is the temperature change in the subpolar North Atlantic, what we call the subpolar gyre region, because it describes the location south of Greenland rather well, and we see the cooling there. And we know it's related to a weakened overturning circulation, bringing less heat into that region, and we then used an ensemble that is many different climate models, state-of-the-art climate models, to calibrate between the observed temperature change and the presumably change in the overturning strength that is causing this temperature change. And therefore, we can see, looking at the observed temperature change, this relates or translates into a weakening of 3 Sverdrup since 1950, and that is 15% of the overall strength of the overturning circulation.
Right, and the Sverdrup is named after the Norwegian scientist Harald Sverdrup, and it's a measurement of ocean used in ocean science. And Wikipedia says the entire global input of fresh water from rivers to the ocean is equal to about 1.2 Sverdrups. And that would mean the reduction you're talking about in the ocean current in the Atlantic is about twice the total volume of all river water flowing into the sea around the world. That's a huge volume of change.
You're completely right. You have to keep in mind that we also talk about a huge current system. And I mean, just the width of the Gulf Stream is a couple of 100 kilometers, and then it goes down into deeper layers. But nevertheless, you're completely right. We're talking about lots of water being moved there or being not moved anymore.
Let's move on to Ireland and the UK. Liefke, how could a weaker Gulf Stream affect the weather there?
Well, this is complicated, and I have to admit that I'm not an expert talking about changes in weather. But what we know or what we think is that actually the winter surface air temperatures in Western Europe, if you look at them, they are up to 10 degrees higher than the zonal mean at the equivalent latitudes. So it's much warmer here than it is, for example, in Canada in wintertime. And this is largely due to the heat released by this ocean current system in the North Atlantic, and then the warm air is moved. The heat is transported toward Western Europe. So we do expect to have an effect there, but we have to study in more detail what exactly will happen.
Do you think the track of difficult and violent storms during winter in the United Kingdom in recent years could be related?
I think it could be, because model results, so studies have indicated that an AMOC decline will influence the storm tracks in Europe and could possibly intensify storminess in Europe. But I do believe that there's more in-depth research needed to confirm this.
A lot of countries have been researching this Atlantic meridional overturning current with good reason. The Americans have a program to monitor AMOC. Another's called RAPID, operating with British funding, and the Hadley Centre in the UK. How do your results compare with what they find?
Well, actually, we find the same decline in the overturning strength in our index that is observed by the RAPID program since 2004. That is when this program was implemented. So our results agree quite well with what has been measured. You just have to keep in mind that our index represents the longer-term changes of the overturning circulation, while the RAPID program gives you high temporal resolution data. But nevertheless, the results agree rather well.
There's a buzz in science about a blob of cold water south of Greenland. That spot in the ocean is one of the few places on the planet that is cooling despite global warming. How does that relate to the paper that you led?
Well, basically, the weakening in the overturning circulation actually explains the cooling trend in that region. So you just have to keep in mind that when you look at a single winter, for example, and you have really cold temperatures then at that point, this will, of course, also be influenced by weather, so by the state of the atmosphere. But the long-term trend in that region and the missing warming, let me put it like that, there, can be explained by a weakening in the overturning circulation in the Atlantic.
How could record cold in the northern Atlantic in 2015 lead to a heat wave in Europe that summer?
Well, this is actually an interaction between ocean and atmosphere that's quite interesting. So when you have cold temperatures in the North Atlantic, so south of Greenland, then this will favor an air pressure distribution that spans around the whole globe at the high northern latitudes, and this air pressure distribution can channel warm air into Europe from tropical regions, and if it persists for quite some while, then you can actually have a heat wave, because you have many days with warm air being channeled into Europe, and this can lead to a prolonged heat wave in Europe.
That's pretty amazing. Did this study predict how quickly Atlantic overturning may weaken in a hotter future?
No, we actually did not research that. I mean, there are climate models, and many climate models have simulated and how far the overturning circulation will change under different scenarios, so depending on how much carbon dioxide we release into the atmosphere in the future. But it's kind of difficult to model such an overturning circulation, and therefore they do disagree on how fast the overturning circulation will weaken. So they agree on the fact that it will weaken, and I mean, we our study showed that it already started to weaken in response to the increased greenhouse gas emissions and the following global warming. But, yeah, as I said, the models disagree on the timing of this weakening, so we should put more effort into studying this into more detail.
Now, I know this isn't included in your study, but I wonder if science has speculated on whether there's a breaking point where the Atlantic currents create a climate crisis, or is this just a slow process that gradually ramps up?
Well, it is a relatively slow process compared to, for example, weather happenings or weather events, but we know that there is a threshold in the overturning circulation, so at some point it really might more or less stop flowing. But here again, the climate models disagree on where this threshold is, so how much warming is needed for the overturning circulation to more or less collapse. And therefore, I just can emphasize the importance of studying this in more detail.
It does sound important. I know there has been speculation for decades that the Gulf Stream could weaken or maybe stop eventually. What do these two studies bring that is new to that discussion?
Well, in my opinion, they bring a really robust evidence that the overturning circulation has indeed already weakened, as predicted by climate models in response to global warming.
Livka, what will you and your group at PIC be researching next?
Well, as you also already mentioned, is that we do know that, or believe that there are influences from the overturning circulation on climate in Europe, in the US, and Canada. And personally, I would like to study the link between a decline in the overturning strength and its influences on weather in more detail. And my next project will actually be to study the link between the overturning circulation and extreme weather and extreme climate events. And I'm both. I'm excited on what I will find, but I'm also a little bit afraid of what this will show me. And so that's my next project.
It's exciting science, but it does affect millions of people and not necessarily in a good way. Is there anything else you would like to tell our listeners?
Yes, I guess I would just like to say that I hope that everybody takes human-made global warming seriously, because, it is true that there are a lot of things we don't completely understand yet, and we do not completely or exactly know what the future will bring us, but it's clear to me that we are affecting our climate at a rather rapid speed, and, so just trying to protect our Earth. That would be great.
We've been speaking with Livka Caesar from the Potsdam Institute for Climate Impact Research, known as PIC or PIK. The title of this important paper is Stronger Evidence for a Weaker Atlantic Overturning. It was published in Nature on April 11th, 2018. Find links to the science we've been talking about, plus other helpful articles, in my radio show blog at ecoshock.org. Livka, thank you for helping us understand these big changes.
Yeah, thanks for giving me a chance to explain everything in detail.
I'm Alex Smith, reporting for Radio EcoShock.
You're listening to EcoShock Radio for the world.
I'm Alex Smith. Get it all at our website, ecoshock.org.
This is Radio EcoShock with your host, Alex Smith.
Forget about the 1.5 degree warming aspiration at Paris in 2015. There have already been 2 conferences of international scientists talking about 4 degrees of warming and beyond. What would happen? A new paper investigates what it could mean for Europe if we get to 1.5 degrees as hoped, or if we go all the way to 3 degrees warming, which could be devastating. Southern Europe could become, quote, a desert, and all European agriculture is threatened by long-lasting and frequent drought. We're talking about 740 million people. The paper published in Nature Climate Change is titled Anthropogenic Climate Warming Exacerbates European Soil Moisture Droughts. Our guest is the lead author, Dr. Luis E. Samaniego, senior researcher at the Helmholtz Center for Environmental Research, UFZ. From Leipzig, Germany, Luis Samaniego, welcome to Radio EcoShock.
Oh, hello.
Why don't we begin with an event often used in your paper, the 2003 drought in Europe? Can you describe what happened then?
2003 was an unusual drought, started very fast, developed over a period of 7 months, started in April or a bit earlier, and covered most of France and south of Germany, lots of parts of Spain. It's estimated that about, I would say just approximately more than 1 billion euros were lost. It's a bit more. I don't have the exact figure. So 2003 was an unusual drought compared to the previous droughts in the 70s. It was a very fast drought. High intensity, started early in the year and covered large parts of France, Spain, and Germany. It has also another effect, which was the highest temperature measure in that time. There are many science papers on this. It created also an enormous heat wave, which, according to some sources, was above 30,000 people, so casualties, mainly elderly who could not support the heat overnight. So it was terrible for many reasons. The low flows were also a problem. Many stations need to shut down, and electricity might become a problem. Drought is a terrible social problem at the end if you're not prepared, and especially in this kind of events, which are very fast. So that was 2003. From the greenhouse gases, there are studies quoted in the paper you mentioned. There was an enormous amount of release of carbon because plants that cannot absorb any more CO2 from the atmosphere. And in these months of the drought, it is estimated that you release so much carbon that you unnade the work done by 4 years or 3 years of normal vegetation growth. So it has impacts in all aspects.
Yes, the climate feedback is amazing. I mean, normally plants do sequester carbon back into the soil and down into the roots, but in this case they couldn't. Does that present a positive feedback where higher temperatures can lead to more CO2 emissions from the land?
Yes, because plants tend to protect themselves if they have problems with water supply in the roots and the temperature is too high. They close the stomata and they stop transpiring, so the whole cycle stops and the CO2 in the atmosphere remain high at high levels, and that will continue over days and over even months. So this is the feedback that the heat waves and the drought produce in respect to CO2.
Given your studies, is it possible the extreme drought of 2003 could become the new normal for parts of Europe if the world warms too much?
That's what we found exactly, is to define a drought, we need to have a threshold. And the threshold we normally define, imagine a 2-meter depth column of water, of soil. 50% of the soil is more or less, let's suppose, is voids. So water can fill in on these voids that we call porosity. And at a certain level, if it's, let's say, 20% of that available water capacity, if the system is below this level, you call it a drought. It happens, you can see what happened with when you have a plant in your house and you've forgotten to water over days. Plants start dying and the stomata is closed and you are below the wilting point. In that moment, plants stop producing and transpiring and respiring. So this is the threshold we need to define to make estimation of drought area and drought extent. But this is relative to every location and is depending on this period of time in which this threshold is defined. This threshold is going to change over time because the climate is non-stationary. So if you define this level, let's suppose over 1 meter you are talking about 30 centimeters of water. Below that, you are now under drought. This is too high for the future because the warming in the future will increase transpiration, will increase evaporation, is going to be in some cases less precipitation. So the system will be below that level. So the threshold become too high, and that is what we call increase in aridity. The system as a whole will become drier, and the difference between these levels will show that the 2003 event will become somehow a normal situation in the future. It will not, in some cases, not even be accounted as a drought because the normal levels in the future will be lower. So it will be a normal summer, probably, in the 2070 or something. But, the result of what happened to the system when you have that kind of summer, you can extrapolate and imagine how the system will become under that situation.
Your paper was written with a team of scientists, many of them from the Helmholtz Institute, but also others from Princeton, I believe, and Southampton University, and from the Netherlands. Why did your team spend so much time investigating the differences between what would happen with 1.5 degrees C of warming and then 3 degrees of warming?
This was crucial for us. The work was funded by the Copernicus Climate Change, basically, and we were delivering these simulations for them. Then, having the simulations, we decided to investigate something that we didn't know before. Most people estimate drought areas and drought durations based on RCP, so a climate scenario. The problem with the climate scenarios is that every climate model has its own climatology inside. So some models reach 1.5 degree, let's say in the 2040, whereas other models reach the 1.5 degree 10 years later or 10 years earlier. And so that means that you cannot use the emission scenario to estimate the drought duration and drought area. You need to mix up all the simulations regardless of the emission. So that's what we did, and figure out at what point in time this model, the global temperature will increase by 1.5 degree, and that is the sensitivity we were trying to estimate. So we reference to the absolute change in temperature and look what happened with the soil moisture and the properties we were trying to estimate so that we can, for first time, analyze the sensitivity of change in temperature to change in drought area, which was not done before because it's a very time-consuming task. It's heavily demanding from the numerical side because you have to handle 60 different simulations that we have in this system. And each simulation is a quite large number of calculations to obtain.
And the results are somewhat different for different parts of Europe, of course. And suppose the world warms by 3 degrees C as a global mean. What does that mean for Spain and its 46 million people?
So for the Mediterranean in general, it's going to be quite complicated. The number of, for example, the change in aridity that we estimated will increase in almost all seasons. And in all degrees of warming, from 1.5 to 3, it's just a matter of how much is the level. So the conclusion is, and all of these changes are significant. They are not statistically significant. That means that winter is going to have less, it will have a change. It's going to be even drier. That means that the whole cycle, the whole water cycle will become affected. They will have less amount of rain in winter, less snow in the mountains. That will create also problems in the summers, water supply of the rivers and the cities. The evaporation at the same time will increase because temperature is increasing. Evaporation of a free land will increase, so it's a vicious circle, and the whole thing will pops up. So consequences that they will lose about the deficit in the worst case, in drought, will be about 35 millimeters in average. And this is an enormous amount of water. 35 millimeters deficit in a column of 1 meter, 2 meters, translated to the space means 35,000 cubic meters per square kilometer. Just imagine the magnitude of this deficit in the worst drought. 2017, last year, Spain had also a horrible drought. About 38% of the reservoirs were half empty, and they didn't have enough water for irrigation. Imagine the deficit of 35,000 cubic meters per square kilometer. It's a reservoir of 100 by 100 by 3.5 meters high. Every square kilometer is missing this amount of water. So agriculture and normal rain-fed agriculture under these conditions cannot be realized. You need to have a sophisticated equipment probably, or irrigation systems that are drip irrigation. Everything is possible, but it's extremely expensive, and people should start thinking where the water has to be stored. You cannot store in dams. You see what is happening at the moment. Dams become empty by end of the year, and next year again the same problem. And then you are expecting to have a winter to replenish the reservoirs, and in winter is not raining again. You will have long droughts, and at some point the system will break down. And this is what probably, that's the horror scenario I see. Of course, there is going to be some gains for other regions in Europe. That's basically the boreal parts, and the boreal and the Scandinavia will have the opposite situation. They might get in winter more water. Increases in precipitation will lead to higher low flows, and that means that they will store water. But for the south, it's a sad situation. If these climate models are in the right path, and this is what is going to be, it's not a nice future, I would say, for everyone.
Now, in between a possibly wetter Scandinavia and a very dry south, you have previously published on the hydrology of Germany. What are the new projections for water availability for Germany under 3 degrees of warming?
It's going to be different from what is now. It's going to have a hot summers, and we're going to have less water, but not comparable to what is in the south. I don't have the figure in mind, but if you check the amount of average number of months per year is going to increase from, let's say, 1 month per year. Because assuming the old threshold, 1 month per year will increase to 3 months per year in the south of Germany. In Goodbury and northwest and northeast will be probably a bit drier than other places because of the characteristics of the soil and rainfall patterns. It's going to be also different because Germany does not have almost no infrastructure for irrigation. And so having a 1 month extra deficit might create also problems for the plants living in this environment and for the agricultural systems which are mainly based on rain-fed agriculture. Going to be a problem for maize plantations, for example. 2015 was a problem. We wrote a paper on this, and it was not a big drought, but it was enough to reduce 10% of the crop yield. And it was just a minor drought, so to say, compared to 2013. And these droughts we have measured since 2000 or 1970s compared to the future droughts are not comparable. What is coming is probably much larger and stronger and larger magnitudes.
Europe produces a lot of food, and agriculture is extremely important in this picture. And one of the recurring themes in this new paper is the possibilities of adaptation to coming changes in Europe. Are there other kinds of adaptation other than, say, irrigation and better water storage that we should be thinking about now?
I think we should start thinking on probably different kinds of storage for water supply and for irrigation, probably underground storages to avoid evaporation during summers. We cannot count with groundwater. That is extremely expensive. We cannot start pumping groundwater. It's first of all, it's quite expensive. You need electricity. Second, it's protected by law. In Europe, you can't just pump. You need permissions. That is likely not going to be accepted. And then is a resource that is not refilled in the next year. Is water reaching the groundwater level takes years to be there. So we need to find out other methods. Probably sophisticated techniques for agriculture will make possible to have same levels of production having drip irrigation. The Israelis have already very sophisticated methods. But as I said, this is not for enormous extensions. Germany has large areas of agriculture, France the same, and Spain the same. And high-tech agriculture is quite expensive. I don't know what consequences would have. You need to ask the experts in agriculture production what these are the consequences. What we concentrate was to estimate the deficit from the point of view of the hydrology and meteorology. But I guess it's going to be highly complicated to supply.
It sounds like a big experiment we're running on the Earth. Do we really know what's coming?
Well, that's exactly right. We're running an unknown experiment on the only planet we have. If somebody were to propose doing this kind of experiment, they would be locked up as crazy because it's the only planet we have, and yet that's the experiment we're doing without knowing fully what the consequences are.
Covering the world, this is Radio EcoShock with Alex Smith.
This is Radio EcoShock. I'm Alex with my guest, Dr. Luis E. Samanyango from the Helmholtz Center for Environmental Research in Leipzig, Germany. We're talking.
You're listening to WZBC Newton 90.3 FM. You can check in if you'd like to. If you're one of the 36, if you're wondering, you can check in at 617-552-4686. We've got about another 14 minutes of Radio EcoShock. A lot to think about today.
Talking about drought as the new normal in much of Europe if global warming goes, say, beyond 2 degrees C. And your paper points at an important problem that much of our planning and our thinking is based on increasing heat only, but water is really the key to life, isn't it?
Right. Without water, we can't live. Plants will die in a couple of weeks, and our water supply for cities is coming basically from the exfiltration from the soil, and that will create a drought in the rivers, and the rivers will get low flows, reservoirs will be empty. Having low levels in soil moisture would also imply to have a drought in the groundwater levels, so that the levels in groundwater will decrease, and replenishing groundwater is a problem. It takes a long time to do. So it's going to be a big problem how you manage the water resources in Europe if the warming continues. And that probably can be extrapolated to any other semi-arid region in the world. We hope in the future to do similar analysis, but I would say it's the same kind of pattern that you will observe.
That was one of my thoughts on reading this paper, the research that should be done on the impact of drought on cities, because if long-standing drought becomes normal in southern Europe, we may see cities rationing water, as recently happened in Rome, or even run out of water, like Cape Town in South Africa.
That's my thinking. We have been trying and expending too much water. We probably need also to think on efficiency systems, so increase the efficiency of the water supply. Every drop of water has to be protected, recycled, and take care about this thing. We cannot just spend water. Water quality will be the second issue that we will have. Low levels in reservoirs increase other problems. It leads to eutrophication, for example. It might lead also to algae booms, and that increases the costs of treatment. At the same time, you can treat the water, but you need more electricity. But the thermal stations and the nuclear plants cannot produce electricity if they don't have cooling systems. So it becomes a vicious circle. You will not have the electricity unless you start burning more fuel from fossil fuels, or you need to probably start doing desalination to supply water, but it's also very expensive, and you need a lot of energy, solar energy probably, which again needs investment. So it's a very complicated problem. I think the study was trying to make a warning and say, look what is coming. We should start thinking what we are going to do in the future, how to administrate and how to operate and plan the new infrastructure so that this collapse that you mentioned in Cape Town, for example, or Rome, do not happen every year in the south of Europe.
You know, when there was a major drought in Australia in the Murray-Darling Basin, some of the farmers there were so discouraged that they did commit suicide, and there's a lot of tension on the whole social fabric when things are too hot and too dry for too long. I think that's another factor, the social stress that is underlying